Nutrigenomics. Okay, right off the bat, that sounds complex, and you probably don't know a ton about it. And that's perfectly fine, because we're gonna break it down so if someone ever asks, you'll be ready. Alright, real talk, odds are you're likely never gonna be asked about this in an informal setting, but hey, maybe someday you'll end up on Jeopardy and be able to impress Alex Trebek with your knowledge of the subject. Or at the very least, by the end of this video, you'll be able to quote some fun facts. So to start, nutrigenomics, as far as the word is concerned, is a fusion of nutrition and genomics. Now, one of these is a little easier to explain than the other. Nutrition, as you likely know, deals with the stuff you eat. It's nourishment, and the field of nutrition looks more closely at the components of what you're eating. That's really the biggest part you'll want to keep in mind as we move forward. It all relates back to food. With that squared away, we can tackle the slightly more complicated topic that is genomics. The key to genomics is that it's related to a concept you are probably more familiar with, genetics. Just looking at the names next to each other, you can see they share some etymology. We're not too concerned with going all the way back to the root word of Genesis, but skip forward a bit and we have the term gene. Not like the clothing or second cousin you only see on the holidays, but rather a sequence of DNA or RNA that codes for a molecule that has a specific function. Essentially, genes make you who you are. They determine your traits and to what extent your body responds to various stimuli. And it's that latter bit we're most concerned with, because bringing it all back front and center, nutrigenomics looks at the relationship between our genes and what we eat. In all likelihood, you were already aware of this in some form and just didn't have a name for it yet. For example, things like lactose intolerance and gluten sensitivity. The heart of these issues is that the body isn't responding the usual way when ingesting these substances. With lactose intolerance, it's an issue of not producing enough of the compound that breaks down the milk sugar. With gluten, it's an unwanted response from your immune system. And ultimately, it's your genes that end up influencing these factors. But there's also another side to this coin, and that's how what you eat can affect aspects of your DNA and genes. Such as, a lack of the specific B vitamin folic acid can put you at a greater risk for compromised DNA repair, which can lead to mutations. Said mutations could then cause a whole host of other issues. Several other deficiencies can likewise play a role in the development of long-lasting diseases like diabetes and obesity. You can start to see how these two sides interplay, with diet and genetics each exerting a certain amount of influence on the other. But now that we have that outline, we can discuss what this means in the wider scope of nutrition. Because information is just intangible data until it can be applied to something. In this context, the biggest takeaway is highlighting the importance of a personalized approach to your health. Broad recommendations are nice and important in their own right when it comes to establishing a baseline, but it can't apply to everyone. We're all different, and nutrigenomics emphasizes that fact. Even if you fall somewhere in the healthy range nutritionally speaking, you're active, don't have allergies, and eat right, there's still more to learn about how your body responds to and processes food. Going along with this idea, there's research to suggest that your genes can influence the bioavailability of nutrients. Before we go any further though, let's back up and define that word. Bioavailability is, in a nutshell, the concept that nutrients from those freshly opened pecans aren't 100% absorbed for use by your body. These biological machines of ours aren't nearly that efficient. So the degree to which we can utilize these nutrients is important to consider. An example of how this information is already being used is iron. Simply put, the source of the iron determines its bioavailability, with our bodies absorbing anywhere from 15 to 35% of iron consumed from animal sources and only 4 to 12% from non-animal sources. And just from me throwing up those numbers, you can see that even within the groups themselves there's a range. And lots of different factors go into determining how much iron you absorb. Animal source, aka heme iron, can increase non-animal, aka non-heme iron's absorption rate, as can vitamin C. And as I mentioned, nutrigenomics plays a role in all of this as well, but it's not always a good thing. In fact, one condition, hemochromatosis, sounds good at first, but can actually be a real issue. It's a problem where, because of your genes, the body absorbs around 4 times the typical amount of iron, even up to 100% of what's consumed in some cases. How your genes specifically cause this can vary, but without getting too complex, the end result is low amounts of hepcidin, the hormone responsible for regulating iron absorption. Thus, your body takes in and stores more. Like I said, it sounds nice on the surface, getting more bang for your buck, but that much iron being absorbed can cause serious issues because the body isn't able to get rid of that extra iron fast enough. It just isn't equipped to handle that, and as a result, the main treatment for this condition is bloodletting. Which, considering the costs of the American healthcare system and the fact that you might have to be treated as often as once a week, you're probably better off befriending a vampire. Sorry, we're getting unscientific and off topic, but I hope you see what I'm getting at. Extreme cases are convenient for showing the effects nutrigenomics has on our diets, but each of us has a unique genetic makeup that influences these things even if it's on a smaller scale. And it's important to know how your body is going to respond so things like treatments and recommendations can be optimized. Especially so as we get older and in general become more susceptible to deficiencies and diseases. And the nutrients themselves are the other half of this equation, in some cases affecting the facets of our genes and DNA. All this being said, nutrigenomics is an emerging field that warrants further research, but it's likewise a field full of potential that could play a critical role in battling the rise of chronic illnesses. Poor nutrition is bad enough on its own, but the potential compounding of issues on a genetic level really puts things into perspective. And I think that's where we'll leave it. Thank you so much for watching. Be sure to share this video around if you enjoyed it. I've been Logan, and I hope you learned something. See ya!